Welcome back. Today we'll look at paper 22 of the May-June 2024 series. And as always, the mark scheme has already been released. So as well as watching this video, I would recommend checking the mark scheme too. And yeah, of course, this video might go on quite a long time, so I'd recommend to watch at 1.25 or 1.5 times the speed. Right, question 1 says, tick one box to identify a method used to design and construct a solution to a computing problem. So, when it says design, of course, this is talking about the design stage. And I think, the acronym that I use is all dogs can track. Right, so yeah, all dogs, yeah, CT. I think another one you can also say always double check twice, right? That's another good way. So of course A, right, analysis, design, coding, and testing. So yeah, obviously here it's saying, what happens during the design stage? Well, it's not going to be the analysis because of course, that's another stage. Likewise, coding, that's another stage. Testing, that's another stage. So yeah, here then the answer is going to be flowchart because, let's say during the design stage, of course, one thing we can do is make a flowchart, right? Of course, we can also write pseudocode. We can also do things like, let's say, structure diagrams, structure charts, and, various other diagrams too. Right, 4 logic functions and 5 standard symbols for logic gates are shown. Right, draw one line to just link them together. Right, not all standard symbols will be used. Right, okay, so and then, hopefully we can remember this, right, and literally just looks like the D. The D in and. Right, so XOR, of course, this is going to be OR, but then it's going to have the extra line. So, right, that's going to be this one here. Right, NAND, this is going to be and, right, then just with a circle in front, because, yeah, the circle means the not. So that's going to be this one. And then, yeah, or, of course, that's going to be this one here, this kind of spaceship, as some people call it. And then, yeah, hopefully we know this one, right? This is just going to be not. But, of course, yeah, we only need these 4 lines. Right, then we want to identify 3 different tasks in the analysis stage of the program development lifecycle. Now, I'll be honest, I actually forgot this one. So the first one we can say decomposition. And decomposition, this just means, you take a problem and then you break it down into the smaller sections. So let's say your problem is, someone wants to say, we want to make a video website like YouTube. Well, you can break that down into the individual problems or, the individual parts. And for example, one part might be, let's say, creating user accounts, right? Another part might be uploading videos. Another part might be, comments, replies. Another part might be searching. So of course, you're just breaking down this big problem of creating a video website, into the kind of individual features or individual problems. Right, another one can be abstraction. So abstraction, this is where, let's say, you take a complex problem and then you just remove all of the unnecessary details. So, I think a common example they usually use in the books is, let's say you have a map and, of course, I don't know, maybe it's a subway map. Now, if it's a subway map, of course, all you literally need is just, the sort of different subway lines. So, yeah, I don't know, maybe something like that, if we've got 3 subway lines. Now, of course, for a subway map, we don't also need the roads on top of that. We don't need the parks, the restaurants and everything. Of course, we want to remove all that unnecessary detail and only have the subway lines. So yeah, that's what abstraction is really, just removing unnecessary detail. And then for the next one, I think we can say 2 really. So one you can say is kind of identifying the problem. But I think a better one we can probably say let's say maybe requirement gathering. So this is where you just basically create a list of features that you want. So again, for the video website, you say our requirements are it should be able to have users upload videos, comments, search, create playlists. Right, so yeah, just create this list of requirements. And I think one they sometimes mention is also a feasibility. Maybe we can say feasibility study. I think there should be an extra L and then an extra I. So I guess you can call it feasibility analysis or feasibility. Feasibility study. And again, this is just trying to work out is this actually possible? Because let's say if someone says, I want a website that will have I don't know, 1 billion users and we want to run it on this particular hardware, with this particular database. Well, maybe if you try to actually do that, it's going to be too slow. It's just not going to be feasible. Yeah, or of course you say, I don't know, we want some like technology that doesn't even exist. So yeah, of course you have to make sure it's realistic. Right, the next one, a program needs to make sure the characters input for a product code meet these rules. The product code is 6 characters in length. The first 2 characters must be, big P and D. Right, then the last 4 characters must be a number in the range 1000 to 9999 inclusive. We want to identify 3 validation checks and state how each check would be, would make sure the product code met one of these rules. Right, so if we just go through them one by one, of course, well, the first one is just going to be a length check. So let's just say that, right, length check. Let's say to ensure, right, product code, is 6 characters. Maybe 6 characters long or 6 characters in length. Right, so the next one, I mean, I guess here we can call this a format check, because yeah, we're checking that the string starts with this, big P and then big D. So right, let's go format check. And again, let's just go ensure. Right, so ensure product code. Right, starts with, let's say, I guess what, PD. And then, we can also say, right, and ends with 4 digits. I think that should be fine. And then check 3, well, this is just going to be a range check. So let's say, maybe, I don't know, let's say ensure last 4 digits. Or maybe, last 4 characters. Right, are a number. In range 1000 to 999. Right, 2, 9999, right, inclusive. So I think this question is not too difficult, I mean, it's literally just rewriting this. And to be honest, I mean, here it kind of tells us length, here it tells us range. I guess, this one we need to recognize that this is a format. But the other 2 are not too difficult. Right, then we want the, so the program design will include a pseudocode algorithm. Assume that the product code is stored in the variable product. And we want to write the pseudocode to make sure that the product code is 6 characters in length. Right, so let's just hop over to the website and we'll do that. So I think here, I mean, it probably wants us, I mean, it's talking about input, so I think it probably wants us to actually input this product code as well. So let's just go ahead here then. Alright, we'll just go output. Let's say maybe enter product code. Right, then we can just go input. And so here then we're going to go input product. And then what we can do, I mean, we could put this inside a loop. But I think usually they like to have it where you have one outside the loop. And then if there's an error, right, then it's going to output a different error message. So in order to do that, well, then we just go while, and let's say while length of product, right, is not equal to 6. Well, then what we want to do is we just want to output again. Or let's say, right, product code should be 6 characters. Right, let's say try again. And then we'll just go input product. Okay, so let's just run this and test it. So enter product code, let's go ABC. Then it says product code should be 6 characters. All right, let's try again, PD 1234. And then here this accepts that. Now, of course, we don't actually need this initial, this kind of initial output and input if we don't want. So we could just say, maybe enter product code. Let's say 6 characters. Right, and I think, I mean, actually, this is how they do it in the mark scheme for this particular question. So again, let's just try, I don't know, PD, or that's going to be, invalid, right, PD 1234, and then it's going to accept it. So again, it's kind of up to you, right, if you want the initial message and input, and then kind of like the error message, right, or if you just want to do it all in a single loop, right, that's also fine. Right, so the next one it's kind of the same. We just want to write the pseudocode to make sure that the first 2 characters of the product code are PD. So effectively we can keep the same structure, just this while. But then rather than, well, while length is not equal to 6, what we're going to use is we're going to use substring. And this will be substring of product. Right then, so then we want the starting position. So the starting, well, let's say the starting index or position is going to be 1. And then the number of characters we want to get is going to be 2, because we just want the first 2 characters. And we're going to check, right, while that's not equal to PD, yeah, then we can do this. I mean, I don't know, let's say like must start with PD. Yeah, hang on, I'm just going to use the escape character to actually have quotes inside this string. Right, so enter product code must start with PD. Let's go AB, AB 1 2 3 4. Alright, so that's going to give us an error. And then yeah, this time it works. And of course, if we try lowercase, right, that's also going to give us an error. So yeah, we do have to use uppercase, which is yeah, I guess as it should be. Right, next one, a high-level programming language makes use of arithmetic, Boolean and logical operators. Right, we want to state how each type of operator is used and give an example statement in pseudocode for each one. Right, so okay, so I guess here then we just give the general description. So we can say what used to perform mathematical operations, because I mean arithmetic is going to be what addition, subtraction, right, multiplication, yeah, etc. Right, example, I mean let's go what 4 plus 5, yeah, that should be fine. Right, Boolean, so this is going to be like what and or not. So I guess we can say maybe to check, yeah, I mean, I don't know, we can say like to check various conditions are true. Yeah, maybe check if various conditions are true, that should be okay. So yeah, for an example, let's just say, I don't know, maybe like did homework. So let's say, right, did homework equals true. Okay, hang true. Right, and let's say the logical condition, I mean here maybe let's go or. Yeah, I don't know, or we can go like, I don't know, like retook, or yeah, maybe retake equals true or something. I mean, yeah, I'm not really sure why this would make sense, right? Did homework or retake it, there's yeah, probably no connection, but just as an example. Right, and then logical, so this is going to be, I mean, often these are just called comparison operators, and I think for me, comparison makes more sense, because, otherwise logical, you can get confused with, sort of and or XOR, right, not. Yeah, of course, XOR doesn't exist in pseudocode. But I mean, logical, that's going to be what, greater than, less than, greater than, or equal to, yeah, equal to, not equal to. So I guess we can say maybe to compare values. So for example, I mean, let's check, I don't know, if A is greater than or equal to B, right, just something like that. Number 6, it says totaling and counting are standard methods of solution. Numbers are input, the number, right, 99999.9 is the last number to be input and is ignored. Right, we want to write an algorithm in pseudocode to total the numbers input and to output the total. Right, we do not need to validate the input. So let's just go ahead and do this. Right, I've just copied the instructions there. Okay, so I mean, here it doesn't say we need to declare, but it also doesn't say that they've already declared. So I think in that case, I'm just going to declare just in case. Because, I mean, yes, sometimes they do actually want us to declare. Right, so here then, I mean, I think first of all, we're going to need some sort of value or user input. Right, we're going to have another one, let's call it total. And then, yeah, here, well, let's just make it a real. And the reason it should be a real is because, well, here, possibly they can enter this, obviously, yeah, 999, right, 0.9. So if we make it an integer, it's going to give us an error when they enter that. Right, then we can just initialize. So let's just initialize total to 0. And value we actually don't have to initialize because we're just going to input that. Now, I'll actually show you how I did it. And to be honest, in the mark scheme, they actually do it in a kind of cleaner way, right, with less lines of code. But yeah, I mean, again, I'll just show you my way, which, to be honest, I mean, for me, it seems more simple, like logically. Yeah, the way they do it in the mark scheme is kind of quite clever, right? There's a little trick. So what I did is I just go repeat until. Of course, you could also use a while loop as the same. But let's go repeat until, and this will be what value is equal until this, nines. Right then, of course, it's going to stop. So here, let's go output. Let's go get enter number to add. Right then, we just want to input that into the value, and then what you've got to think is that here it says, so here it says, right, this nines, right, that's going to be ignored because we wouldn't want to have 1, and then let's say next time they enter this, because then it's going to give us a sum of like 1000.9. So yeah, that's why, I mean, here we would probably want an if statement. So we say, right, if value is, let's go not equal to this, right, then what we want to do is add it to the total. So hopefully you're familiar with how to, add to the total, right, just go total and then assign total, and then plus the value we're adding. And then, yeah, I think that should be okay, right, and then let's just output total at the end. Yeah, we'll test that, see if it works. Right, so let's go 1, let's go 2, let's go 3, and then we'll just try this one at the end. And then, yeah, here, so you see this is 6, all right, that works. And to be honest, sometimes they do like a message as well, so let's go total is, and then, yeah, something like that. Right now, of course, this works, and like, let's say, for example, if we didn't have this if statement, let's just delete this. I mean, yeah, hopefully you know what the problem is going to be, right? If we go 1, 2, 3, and then let's do this, all nines. Well, now it's going to say the total is this because, of course, it's also added this one. Now, I think the way they do it in the exam is, I guess we can have the output there. So they actually put this total before the input. So if you think the first time, well, the total is 0, and I guess, yeah, the value is also 0. So here it's just, well, 0 plus 0, okay, total stays at 0. Then we input the value. And of course, if they sort of first input this, well, it's just going to stop. But let's say they input 1, of course, it's going to add 1 right on the next iteration of the loop. Then if they enter this, like all nines, right, then it's going to stop. So let's try that again, right, 1, 2, 3. Right, hang on, let's try again. Right, 1, 2, 3, and then, yeah, these nines. And then, yeah, here you see this also works. So again, I mean, for me, the easier way, at least with my logic, is to use an if statement. But yeah, if you don't use an if statement, you then have to do this total before, and then you have the input afterwards. And yeah, that's also going to work. Whereas, of course, again, if we have this input before the total, well, then we're going to get the same problem as we saw before, where now it's going to add, it's going to add these nines to the total. Right, so yeah, hopefully that makes sense. Right, the next one, we want to write an algorithm in Pseudocode to count and output the number of input values that are greater than 100. And again, right, we do not need to validate the input. Right, so I mean, basically, we can just use the same code as we have here. Yeah, so let's just delete this a second. And I'm probably just going to remove this. I mean, in fact, right, let's start again. So what we want to do then, well, let's just declare. And let's declare a count, right? So a count can be an integer because, of course, well, we can only count a whole number of times. Right, again, let's go maybe like value or user input. That's going to be real. And this time, again, we also need to assign count 0. And then let's just go repeat. And again, we'll just, okay, I mean, right, let's say this time I'll use a while loop. Of course, we can use repeat until, we can use while, but let's just demonstrate with the while loop instead. So what we want to say, well, while value is not equal to this, these nines. Right, then what we want to do, let's go output, maybe enter a value. Right, then we're just going to go input the value. And what we'll do is we'll have an if statement. So we say if value is what, greater than or equal to 100. Okay, no, right, greater than 100, right, not greater than or equal to. Right, so if value is greater than 100, and then here we're just going to increment the count. So again, hopefully you're familiar with how we do that. And then probably, yeah, we just want to output that at the end. So let's just go output count. And yeah, let's try that, see if it works. So let's go 5, let's go maybe 100, and let's go 105. And then we'll just stop. Okay, right, so here it says, right, okay, so yeah, here then there's a slight problem, because obviously it thinks this 999 is bigger than 100. Now, yeah, I think here again we can probably also ignore this. So the way we can do that, we go, well, if value is greater than 100, and value is not equal to this. Okay, so this is one way of doing it. So yeah, and then let's go 100, let's go 101, and then we'll just do this one again. Okay, so now it says 1, that's correct. Alternatively, you can do as they've done before, where, for example, you would do this first. Right, then you have the input. So let's just try and rearrange this. Right, and then I think now we wouldn't need this one. I mean, let's think about this, right? So, well, value is going to start at 0. So yeah, while value is not equal to this, right, that's true. Right, if it's greater than 100, all right, that's going to be false because it's going to start at 0. Yeah, then let's say they input, this 9's, right, then it's just going to end. So I think this should work, and let's just try this. And yeah, that says 1. Okay, so this seems to be working. Question 7 says an algorithm has been written in pseudocode to find and display the maximum and minimum values in an array of 1000 positive numbers. Right, the array list starts at index 1. Okay, so let's see what we have to do. Right, first we want to give a line number for each of these type of statement. Okay, so yeah, this is not too difficult, right? We want to find an assignment statement. So of course, an assignment statement is basically anywhere we see this arrow. I mean, not necessarily. I mean, yeah, this one is kind of. So this is like an assignment statement inside the for loop. Although, yeah, I probably wouldn't give this, right? It's better just to go with the basic ones. So, of course, the obvious ones were line 1, line 2, right? Also line 6 and line 10. So let's just go line 1. Right, selection, well, that's going to be if or case. So I guess, yeah, line 4, they have an if statement. And then iteration, well, for loop, while loop, or repeat until. So I think here on line 3, okay, they have a for loop. Right, then we want to identify the line numbers of 3 errors in the pseudocode and suggest a correction for each error. Right, so for me, what I like to do is I like to read all the code, one line at a time, right, find all of the errors, and then, yeah, once I've found them, then I'll write them at the end. Because otherwise, if you start trying to write the errors as you're reading the code, yeah, maybe you'll make a mistake, maybe you'll miss one. So yeah, I think for me, it's better to find all the errors first, okay, then actually write them down. Right, so first line, they take this list index 1, they assign that to the maximum, right, that seems okay. Again, they do the same for the minimum, right, that seems okay. Right, then they start the loop, so right, for counter, they assign that to, right, up into 1000. Yeah, that seems okay. Right, then they say, well, if list counter, so list counter, this is the current element. So if the current element is less than the max, then they take the current element and they assign that to the max. So I think, yeah, this is going to be one error. Right, this should be if list counter is greater than the maximum. So yeah, let's just sort of underline that, right? That's going to be one of our errors. Right, then they have end if, yeah, that seems okay. Right, then they go, well, if list count is less than min. So if we look here, right, this count, I think that should be counter. Because, yeah, of course, this counter, this is the for loop. So yeah, that's going to be another one of our errors. Right, then they take this, yeah, list counter, so the current element, they assign it to the min. Right, that seems okay, but then if we look here, they have end while. Now, of course, we've got an if statement, so it should be end if. And yeah, that's going to be our third error. So let's try and write that. And yeah, maybe let's zoom out just so I can see it. Right, so line number 1, that's going to be, line 4. Right, then just to write this, so I guess we just go if. Right, yeah, if list, right, index counter. And then that's going to be greater than max. Right, the next one, line 8. Right, so another if statement is going to be if list. And then, yeah, this time just make sure to spell counter correctly. right, and then that's going to be less than min. Right, then the last one, I guess, well, line 11, and that should just be end if. And since this is a keyword, right, make sure to do it in capital letters. Right, number 8. So a logic circuit is to be built to control the opening of a safe used to store money. Right, there are two keys A and B and a time switch C. The safe can only open if both keys are used and the time switch is off. Right, then we want to write a logic expression for this problem. So if we look at this, well, okay, we see key A, right, not used is 0, right, used is 1, again, same for B. Right, C, obviously, switch off is 0, on is 1. And then, so X, right, well, X represents the safe, and if it's open, it's going to be 1. So let's just go here at X, because effectively we're saying, well, X is true, right, if, and then, you know, the following conditions. So the conditions are if, right, both keys, okay, so let's say both keys are used, so that's going to be A is true, right, yeah, and B is true. So what we say, well, we say, hang on, right, yeah, okay, A and B. And I guess let's put that in brackets. Right, and then, yeah, also, and the time switch is off. So we're then going to have another and then the time switch off, right, well, that's going to be 0. So in order to represent that, we just go and, not C. Yeah, and that should be okay. Right, then we want to complete the truth table for this problem. So just to write this down, right, let's go A and B. Right, yeah, A and B. Right, then we want to go, I guess, just not C. And then, yeah, finally, we can just, like, and them together to get this X. Right, so again, I mean, if you've seen the other videos, the way I like to do it, I like to look for where they're 1, right, or where it's true. So A and B, of course, this means, well, both of them have to be true. And, right, that's only going to be these two rows here. So, yeah, these two rows are going to be 1. Right, and then let's just fill in everything else with zeros. Right, then if we go not C, well, of course, that just inverts, right, looking at this column. So that's going to be 1, right, so, yeah, 1, 0, 1, 0, 1, 0. Right, then we just want to add them together. So using the same logic, I'm going to look for where are they both 1. So that's just going to be this one. And then, yeah, I think everything else is therefore going to be 0. And I mean, this makes sense really, right? Because, again, we're saying that, well, the safe can only be open, right, if it's used. Yeah, and B is used. All right, and, you know, the switch is off. So effectively, like, well, there's only one situation, right, out of all of these 8 situations, like, where the safe can actually open. And I mean, yeah, that's what we're saying here, right, because we're saying, yeah, if key A is used, key B is used, but, you know, C is turned off. So yeah, this seems to be correct. Alright, so the flowchart represents an algorithm, right, so first then we assign false to A, we also assign B to, well, we assign 1 to B. Then we check, so what is or if. Right, so is this current element greater than the sort of next element? Right, if it's not, well, then we take the current element, assign it to this T, right, probably a temporary variable. Right, then we take the next element, we assign it to the current position. Right, then we assign the temporary variable to the, to sort of like the next position. Right, then we just set A to be true. So hopefully you can see, you know, this looks like it's bubble sort. Right, okay, then what we do, so I guess then we go back here and we, this part here, we just increment B. Well, we check, right, so is B equal to 5, right, this is going to be the stopping condition probably. Right, if it's not, well, then we just go back and we do this loop again. So effectively like the next iteration of, bubble sort. Right, if it is, well, then we say is A true. So A is kind of like the did swap, or like not sorted. So I guess, if it's not sorted, well, then we're going to go back and we're going to do bubble sort again. But of course, if it is sorted, or I guess, maybe like if did swap is false, right, then of course we just stop. Right, so it says the array, right, list 1 to 5 used in the flowchart contains this data. Right, okay, we just want to complete the trace table. Okay, so I've just put the windows side by side so it's easier to see. Right, first then we want to assign false to A. Just, looking at this part here. Right, then the next thing we want to assign 1 to B. Right, then we check is list B greater than, well, list B plus 1. So effectively, right, is 15 greater than 17? Right, so in that case it's going to be no. Right, so that means we go here to this, bubble sort part. So then what we do, we assign list B to T. So right, that's going to be 15 goes in this temporary. Right, then we assign, so the next one, right, to the current value. So effectively this 17 goes into this index 1. Right, then what we do, we put the temp in this, next position or next index, and then we assign true to A. So yeah, this A is going to represent, like did swap or kind of not sorted. Right, then what we do, we just increment B, so that's going to go to 2. Is B equal to 5? Right, no. So then we just go back to this, is or if statement again. Right, so now of course we're comparing, well, 2 with 3. So is 15, is 15 greater than 20? Right, that's going to be no. So again, what's going to happen then is 15 is going to go into this temp. Right, 20 is then going to go into this position, and then 15 is going to be put here. And then again, A is going to be put to true. I think we don't really need to write that if it stays the same. Although, yeah, we can just write it, just in case. Right, then again, B is just going to increment. Right, is B equal to 5? That's no. So again, we check the next one. So right, is 15 greater than 5? Well, in that case, yes. Right, so then B just increments. Right, again, is B equal to 5? No. Right, so the next one, then we've got 5 and 9. So is 5 greater than 9? Right, that's going to be false. So here what we say, right, 5 then goes into this position, 9 goes here, and then 5 goes here. Again, right, A is going to be set to true. Yeah, okay, I mean, you're right, let's just write that again. Yeah, okay, alright, and then, well, then we just increment B again, so that's going to go to 5. Right, and so now in this case, is B equal to 5? Right, that's yes. And then we check, is A equal to true? Okay, right, that's also yes. So then again, we just go back, we set A to false again. So I think, yeah, let's start a new line here, right, since we're kind of starting a new loop. Right, we also set B to 1. Right, now what we want to do, so right, yeah, okay, so here we've got 17. Right, is 17 greater than 20? Well, again, that's going to be false. So what we're doing, we're putting 17 here, right, 20 goes here, and then, yes, 17 goes here. Right, then we set A to be true. Right, then we just increment B again. Right, the next time it's going to be what's 17 and 15, if we're looking at this. Right, so here then, what is 17 greater than 15? Right, that's true. Okay, so nothing will happen. And yeah, we're just going to increment B. Right, the next time we've got 15 and 9. Okay, well, that's also fine. Yeah, so again, we just increment B. Right, then we've got 9 and 5. Okay, that's also fine, so just increment B. Right, then, yes, is B equal to 5? Right, yes. Is A equal to true? Right, yes. So again, we just go back one more time. Right, and then so again, let's start a new row. Right, so A goes to false. Right, B goes to 1. And right here then we want to check, so is 20, yeah, 20 greater than 17? Right, that's true. So then B just increments. Right, then we've got, what, 17 and 15. So again, yes, 17 is bigger, just increments. Right, 15 and 9, okay, bigger, just increments. And then, yeah, 9 and 5, again, that just increments. Okay, and yeah, I think that's fine, because, I mean, here there's no output. Yeah, so hopefully that should be correct. Right, so then we want to describe what the algorithm represented by the flowchart is doing. So if, well, I mean, obviously we can see it's bubble sort, and whereas usually, of course, bubble sort is going to be ascending by default, in this case it actually seems to be in descending order, because we've got, what, 20, 17, 15, 9, and 5. So let's just say that. Yeah, let's say, right, using bubble sort. Okay, right, bubble sort. Right, to sort the array in descending order. Yeah, okay, that should be fine. And again, probably one of these marks is for bubble sort, right? One is for descending. So yeah, obviously in that case, obviously, well, it is important to say, right, descending or ascending. Right, next one, a television subscription service has a new database table named contract to store details of their subscribers' contracts. The table contains these fields, right? So contract number. So for example, yeah, some sort of like ID number basically. Right, months, the length of the contract in months, for example, 6. Right, the end date, the date the contract finishes, right, that's going to be a date. Right, news, yes or no. Right, movie, yes or no. Sport, yes or no. Right, junior, yes or no. So obviously, yeah, just all booleans. Right, identify the field that would be most appropriate primary key. So I guess the primary key is going to be this one because yeah, this looks like some sort of unique, some unique kind of identifier. Yeah, right, contract number. Right, then we want to choose the most appropriate data type for these fields. Right, so contract number. I mean, like, yeah, I mean, honestly, like if this is real, you'd probably say something like varchar. But I think here, you know, they usually just say text, right? I think they also allow you to do alphanumeric. Now, I mean, really, alphanumeric is not a valid like SQL data type. However, I guess for Cambridge they use this for some reason. Right, months. Well, we can see months is just going to be an integer. Right, the end date. Well, that can just be a date. And then the sport. Well, let's just say Boolean. Right, then we want to explain the purpose of these structured query or SQL statements. Right, so we select the sum of the months from contract. Okay, so if we think sum, let's say for example we have contract, I don't know, maybe AB like 1, 2, 3. Let's say what DE like 4, 5, 6. And let's say this one has 7 months, right? This one has 5 months. Then what sum months is going to do is going to take all of the columns. Or I don't know. I mean, let's say all of the values right in this months column, and it's just going to sum them. It's going to add them together. So of course, in this case, that's going to equal 12. So effectively, what that's doing is finding the total number of months for let's say the total number of months remaining for all contracts, or the I guess let's say the total length of all contracts. Or maybe let's say to find. The total number of months I know, like of all contracts. Now of course here, you know, this is going to find all of them. Now if instead we had like a where, so I don't know, we could say for example like where I know, like where junior equals like true or yes. So of course that would find like only the people with sort of the children's subscription. Whereas in this case, right, there's no where, so it's just selecting everything. Right, the next one, select count news from contract, right, where news. So I guess this is saying like, where news equals true, right, or where news equals yes. So this is just going to be counting the number of people that are subscribed to this news service. Maybe let's say let's say to count the number of subscribers. Right, to count the number of subscribers. That are subscribed to the news service. News service. Right, then I think maybe just one more. Complete this SQL statement to find the contract numbers of the subscribers that take both the news and sports services. So we want to select the contract numbers. So that's just called contract number. And I mean here it says we only need to select one thing. Here obviously we're only selecting the contract number. Right, then from contract, that's done. Then we want to say, well, where news and sports. And you know, I mean, honestly, like again, you could go, yeah, where news equals true, or yeah, news equals yes. But I think, you know, if we look at their example here, they've just gone, yeah, where news like this. All right, so that's also fine. Yeah, we don't need it equals true or equals yes. Okay, looking at the 15 marker, it says a one-player game uses the two-dimensional 2D array grid to store the location of a secret cell to be found by the player in 10 moves. Right, each row and column has 5 cells, and we see here the starting position is, well, just 1, 1, right at the top left. At the start of the game, the program places an X in a random cell, okay, not in grid 1, 1, so yeah, not in the player's starting position, and empties all the other cells in the grid. Right, the player starts at the top left, and the player has 10 moves. Right, during the game, the player can move left, right, up or down by 1 cell, and the move must be within the grid. Right, you win if the player moves to the cell with X and has played 10 moves or less. Right, you lose is displayed if the player has made 10 moves without finding the X. Okay, right, we want to write a program that meets these requirements. You must use pseudocode or program code and add comments to explain how your code works. You don't need to declare any arrays or variables, right, this has already been done. And all inputs and outputs must contain suitable messages. Right, so let's just go ahead and jump in and we'll try and do this. Now, I mean, I've just declared this grid already because obviously, well, we'll need this if we're actually, you know, testing it on the website. Right, so what we can do then, I think the first one, it says we want to, yeah, place X in a random cell. And again, of course, you know, you don't have to declare this, but for the actual website to work, right, you will need to declare. So let's go maybe, yeah, X, let's say maybe X row. Or yeah, X position or something. Right, let's also go, yeah, X column. And well, we'll just make those integers. Okay, and then I think we can also have integers for the player position. Let's say player row, and let's go, yeah, player column. And then let's think we also need the number, let's say the number of moves remaining, right, obviously starts at 10. Yeah, let's say, I mean, I guess we don't necessarily need moves remaining. We could also call it like number of moves, right? So it's going to count up. So yeah, let's call it maybe not, yeah, I mean like number of moves or non-moves. Right then, is there anything else we need? I mean, I think for the moment that's okay. You know, we can go back and add some stuff, which is why I always like to leave myself some space. Right, so first then, let's just go ahead and we'll just empty. Yeah, we're just going to empty the grid, okay, and then we're also going to put the X in a random cell. So in order to empty the grid, well, this is just looping through a 2D array. So first we're going to loop through the rows, okay, that's going to be 1, and then we're going to go to 5. Right, then we're just going to loop through the columns. Again, that's going to be 1 to 5, and what we're going to do, we're just going to go grid. Okay, make sure to use the correct index, right, so the index is row and column. And let's just assign that like an empty string, right, or yeah, empty character. Right, then we're just going to go next column, and then we're just going to go next row. Right, now then we want to generate the starting position. But yeah, of course, right, not 1, 1. So let's put that in a repeat until. And we're going to go until the X row. Yeah, maybe let's go, right, X row is not equal to 1. Right, or the X column, right, is also not equal to 1. Because, for example, if let's say the row is 1 but the column is 3, okay, that should be okay. And yeah, I think this should work for those situations. Right, so what we want to do then, we just want to generate a random row. So the way we can do that, well, let's go round. We're then just going to go random. So random here, we see that's going to generate a random number between 0 or 1. So, I mean, we don't really want to multiply by 5 because the problem is, right, we actually want the number to be between 1 and 5. So I think what we can do is if we multiply this by 4, okay, then if, and hang, yeah, let's just round that to 0 decimal places. Right, then if we just go plus 1, so this here should generate a random number between 0 and 4. Right, then if we just go plus 1, okay, well then it's just gonna, yeah, then it's just gonna, you know, plus 1, so it goes between 1 and 5. And then basically we can do the same thing but for the column. Right, and I mean, let's just test that, see if it works. I think hopefully it should work. You know, of course, like in the... yeah, okay, so that seems to be working. You know, obviously in the exam you wouldn't have these outputs, but yeah, we're just testing. Right, and I think what I'm going to do, I'm actually just going to create a extra procedure, right, just so we can actually visualize the grid. Now, again, in the exam, of course, you wouldn't do this, but yeah, this is just to help visualize, just to, you know, I guess, yeah, help demonstrate. So let's go show grid. Right, let's go end procedure, and again, we're just going to copy this, so let's copy this loop through the rows and columns. But then what we want to do, we also, and let's make sure just to indent this as well. Right, we're going to declare a line. So this is going to be a string, and basically this will be the current row that we're outputting. And what we'll do is, let's say each row that we loop through, we're just going to assign this line to an empty string again, okay, just to kind of reset it. And then what we can do is we'll say, so for example, I've got these colors here, and let's say if it's empty, then we'll just set it to X. I guess, yeah, if it's the X position, or yeah, if it's, you know, this X row, X column, maybe this can be green, this is the target. But then, yeah, if it's the player row, player column, right, then we can set it to blue. So, right, let's do that. Right, we'll just go, yeah, okay, all right, so let's try like this. We'll go if, right, okay, so if row is equal to the X row, right, yeah, and row is equal, okay, sorry, right, and column is equal to X column. Right, then what we want to do, let's go line. Right, and I guess to be honest, you know, this operator is actually not technically included for IG. This just means concatenation, right, so just joining strings together. And then what we want to do, I guess, let's say this green. And again, you know, if you don't want to do this, you can skip forward a couple of minutes in the video. But yeah, this is just to demonstrate. Which, you know, again, hopefully this will make the video, yeah, hopefully this will make the video easier to understand, right, when you can actually like visualize the pieces on screen. Right, let's just copy this, because rather than saying is equal to X row, this is then going to be equal to player row. And then, yeah, let's check, and the column is equal to the player column. And then let's say in this case that can be blue. Right, then we can just have an else, and let's go end if, and I guess, well, else we just want to go black. So yeah, black is going to be if it's kind of like an empty cell. Right, that should be fine, and then what we want to do as well, once we've looped through the entire column, right, that's when we can just output the line. And yeah, that should be fine. Now, you know, what we can do something like this, where if we just separate like that, and that's obviously a way to distinguish between, you know, this is the sort of first move, the second move, the third move. Right, and then in order to call that, let's just go call, and let's go show grid, and yeah, let's see if this works. Okay, yeah, so now we can see it saying that this is the sort of target position. Now, of course, in reality, you wouldn't actually show this target position because, well, the whole point is the player is trying to guess. But again, you know, just for us debugging, right, it makes it easier. Okay, that's fine. Right, so, right, then what do we want to do? We want to, yeah, so I guess then we just want to set the player's position. So in fact, I mean, let's do that here. We'll go player, right, player column is going to be 1. And let's also do the player row. That's also going to be, well, assigned the value 1, right, or initialized with the value 1. And then, yeah, now we can see that. Right, so the player has 10 moves. I mean, I think that's okay. Right, during the game. Okay, so let's think about what's the conditions of, like, you know, while the game is continuing. So I think let's just have a repeat until. And I guess the stopping conditions, this will be either if and you know, you could simplify this by making another variable, like a win variable. So yeah, maybe let's just do that. We'll just go declare win. Let's go Boolean. yeah, and yeah, okay, I think that's fine. Alright, so let's go, well, until win, right, or yeah, until win equals true. Right, or, and this is going to be what the number of moves is, I guess, equal to 10, or is it greater than 10? Yeah, so I think equal to 10, right, because if they've made 10 moves, then it stops. Right, okay, yeah, all num moves is equal to 10. Right, so that should be fine, and I'm just going to delete this show grid now. Yeah, okay, let's just delete it. Right, so what we want to do inside here then, I guess this is where we want to ask them. Yeah, this is where we want to ask them their move. So I think for this, probably the best way to do it is we can use a case statement. And I mean, we can't really use the arrow keys, but for example, we could use maybe like WASD, right? That's common in games, where, you know, W is going to be up, right? A is left, S is down, and then D is going to be, yeah, right. Of course, you can also use, you know, left up, right down. But yeah, I think WASD is fine. Right, so let's go output. Right, let's go, yeah, maybe enter move. Yeah, I'm going to enter move direction. Yeah, I don't know, like, I don't know, we could go, yeah, W equals up. Right, I mean, let's go get A equals left. Right, so S is going to be down. And then, yeah, D is going to be right, just to explain it to them. Right, so of course, and again, you know, in the exam, you wouldn't have to declare this, but yeah, just for the website, let's do this. Let's say maybe move direction. Right, that can just be a character. So then we're just going to go input into move direction. Okay, and now we can just have a case statement. So let's go case of, right, move direction. Right, let's go end case. And what we'll say is, well, if the move direction is, let's say W, well, then what we want to do is we want to set the player position to be, let's say, the current row -1. But I think we don't necessarily want to do this yet, because again, we have to check, what is it a valid move. So that's why let's go back here and we'll just add some extra variables. So let's go, well, new row, and also, yeah, let's also go new column. And I mean, you know, here you could have like if statements inside this case, but I think if we just do it like this, where we just kind of update the new column, then we can actually validate everything after the case, and it's going to be a little bit quicker, or I guess kind of less code. So what we want to say, well, new column is going to be equal to the player column, right, -1. And then, yeah, really we can just copy these. Right, so let's go, yeah, I mean let's go A. So what that's going to be the new row, and that's going to be the player row -1, because, yeah, left is going to be -1. Right, if we go S, and yeah, let's go D. Right, so S is going to be down, so that's why the new column, and then, yeah, +1. Right, and then D, that's going to be right, so, well, that's going to be +1, but it's going to be the player row. Yeah, let's check I've done that correct. So new column, player column, right, new row, player row, yeah, column, column, row, row. Okay, so I think that's fine. And let's also just have an otherwise in case they enter something invalid. Yeah, let's just say, all right, output, right, invalid, move direction entered. All right, should be, I know, yeah, WASD, right, one of those characters. Okay, and yeah, let's also make sure we also want to set the, okay, yeah, this number of moves. Right, just initialize that to 0. Right, so I think then we want to validate that the move direction, or yeah, we want to validate this, obviously a valid move. So in order to do that, well, basically we want to check that if the new column is, what, greater than or equal to 1 and less than or equal to 5. Of course, yeah, the same for the new row. So let's do that, right? If new row is greater than or equal to 1, right, and new row is greater than, less than or equal to 5. Right, okay, yeah, and new column is greater than or equal to 1, right, and new column is, well, less than or equal to 5. And let me just move this across just to expand it out. Right, then what we want to do is, okay, let's just go here. So obviously here, this is where we want to update the current player row to actually be this new row. And the new column. So let's go player row is going to be equal to the new row. Right, player column is also equal to the new column. And of course, here only one of them is going to change, right? So, okay, yeah, so that's kind of a problem, I guess. Yeah, I mean, so obviously this is where you could have like if statements inside here, right? Alternatively, we can just check. I mean, maybe if we assign the player column to be the new column. So I think if we do this, let's go new column. Okay, well, sorry, right, let's go new row. That's going to be the player row. Right, then let's go new column. That's going to be the player column. Because like what I'm saying is that, let's say, for example, they choose W. Well, W would set the new column. But, of course, the new row would never be set. So, for example, I don't know, maybe the new row would be 0, right? Or, of course, if we've set it before, it would just be the value that we've set before. Whereas, yeah, if we actually assign them to be the current row, the current column, like then, for example, if we choose this W, well, it means that the new row is still going to be correct because, the new row will just stay the same, right? It's going to be the current player row. So, yeah, I think that should be fine. And then probably let's have an error message. Right, end if, let's say, yeah, so let's say maybe invalid move. I don't know, yeah, like not on board. Okay, so I think that's fine. And then what we can do is we can just check if they win. So to check if they win, we want to check what if the player row is equal to the X row, right, and if the player column is equal to the X column. Right, then if it is, well, let's just then set win to be true. And I guess here, yeah, let's actually just initialize win to be false. Right, so I think that should be fine. And then, of course, we also just want to increment the number of moves. Yeah, so let's go number of moves, and we'll just increment that like this. And what we can do, maybe at the end, well, here is where we can just output, if they won or if they lost. Of course, we could also output, if they won here, that's also fine. But I think, yeah, I'm just going to do them together at the end. So let's go if. And the thing is, we don't necessarily want to check if the number of moves is equal to 10, or we don't want to only check that. Because, for example, like if they win on the 10th move, then, of course, that's also going to be a valid win. Yeah, I think that's a valid win. Let me check. Yeah, so if they've made 10 moves with finding it, right, that's going to be valid. Right, so let's go, yeah, if, I don't know, like if win equals true. Then what we want to do, we just want to output you win. And how do they spell that? Like the capital, yeah, I guess, right, just capital W. I mean, let's try and make it just identical. Right, then we'll just have, yeah, let's have an else. And again, right, end if. Right, so of course, well, if they haven't won, then the only way it could have stopped is if the number of moves is 10. So I suppose, yeah, here then we can just go output you lose. Alright, and that, yeah, I mean, that should be okay, I think. What I'm going to do, I'm just going to call this show grid just so we can actually test it. So I guess the place where we can use this show grid, I mean, let's say after they make their move. Yeah, okay, so yeah, I don't know, let's go here, right, call show grid. And I'm actually going to call it just once at the start as well, just so we can see it here. Yeah, and then let's test that, see if it works. Okay, so let's say we want to move to the right, so right is going to be D. Let's go, yeah, capital D. Okay, so, right, yeah, for some reason that's gone down, so why has that gone down? Right, so here then, that's a stupid mistake. Right, okay, yeah, I realise I've done that opposite. Of course, right, so W should be row. Yeah, this is the good thing with testing, of course, whereas, in the exam I would have lost these marks. Right, of course, this one should be column. This one should be column. I mean, let's make sure, so W is up, so the row decreases. Right, and then S is down, so the row increases. A, okay, yeah, I mean, hopefully that's correct. Let's try again. So, alright, I mean, it's the same position, which is kind of weird. Let's try W. So W should actually give us a invalid move. Invalid move, okay. Right, let's try, okay, so S is going to be down. And then, if we go down, okay, we can see that's worked. Right, then let's just try, let's try S again, down. That's fine. And then if we go right, so that's going to be D. Okay, and then, here it says you win. Now, I mean, honestly, here I guess I can make that, big A, big S. Okay, then, D like this. Right, I mean, that's fine. Now, let's try the losing condition. Okay, let's try this losing condition. So maybe we'll just go, I don't know, let's go like right, left, right, left. Okay, so D, and then, right, let's go A, then D, then A, right, then D, A. Okay, so, right, then it says you lose. And I mean, let's count, is that 10, right? So that's move 1, move 2, move 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so that seems to be working. Now, again, I mean, I think, this is working pretty well. Now, for this show grid, right, there is actually an additional method let's say an additional procedure we can use. So if we just go clear, and again, this clear is only actually for the website, it's not like a real procedure for Cambridge. But basically that's just going to clear the console, when we call this. Right, so let's go down again, and you see the console gets cleared, right, which means obviously that only shows us the current position, which is quite useful. But right, I mean, so guys, once I've done this, I think it's always good, just read this again, make sure we've got everything. So place X in a random cell, starts top left, 10 moves, they can move. So I think that's everything. Now, of course, let's just go through quickly and just comment everything. So what we'll do, let's say, reset, and then reset all cells to be empty. Right, let's say generate, let's say generate target X position. And I do realise I have actually forgot one thing. Right, so this grid here, we then do just want to, okay, and right, that's not going to be here, sorry. Right, that's going to be after we've done the repeat until, so after we've validated that it's obviously a valid move. Right, then we just want to go the X row, and also the X column, and we just want to assign that here the, let's go the string X like that. Okay, right, generate target position, I mean, let's say like set target position. I guess here we can just say what, like initialize variables. I mean, obviously this show grid we won't comment because that's not going to be in the real exam. Right, so this one we can just call game loop. Let's say continue until win or lose. Right, this one, let's say get player move direction. Right, this one, let's say I don't know, set the new position. I guess we can say maybe update new position, or maybe let's say update possible new position. Let's say like before validation. Right here, let's say validate. I don't know, let's say validate move is on board. Obviously, this show grid again we don't need. Right here, then we're just gonna check if one. I mean, increment moves, I think we don't really need to comment that. And I mean, I don't know, this one, let's say show, I don't know, show outcome or show results. And again, obviously, this we don't need to comment. Right, guys, so again, I mean, hopefully this video is useful. Any questions, as always, just ask in the video, ask on Discord. Maybe send me an email, and see you again in the next video.